This is precalc 2.7. We're going to model with functions today. When we say in modeling with functions, basically you're trying to find a function that will basically give us some clues on how what describes the situation. And so it's just about finding a function that describes the dependence of one quantity on another. And that is called the modeling. We did this back when, I think it was like 1.7, 1.6, all of those word type problems. But what we're going to do on these ones is we're going to take it to the level of, we're going to maximize or minimize them. And so we know all of these techniques already. So let's go into the fact that we can model the volume of a box. So a breakfast cereal company manufactures boxes to package their product for aesthetic reasons, because it got to look pretty. The box must have the following proportions. It says its width has to be 3 times its depth, and its height is 5 times its depth. That's all it gives us. So that's the question. We don't know its depth, but we know it seems to be all related to its depth. So we got 4 things that we're going to have to do for this. Is that step 1, find a function of the volume of the box in terms of its depth d. So everything based off of d. Step 2 is find the volume of the box if the depth is 1.5. What would be the depth if you wanted a volume of 90? And then for what depth is the volume greater than 60 inches squared? Or volume, inches cubed, sorry. So 4 things that can be done based off of that first initial sentence. Well, the cool thing about it, it's a box. You know the volume of a box. How do you find the volume of a box? Yeah, we should all know that volume is length times width times height. Then they start to make some connections. We know something different about the width. We know something different about the height. They're saying that the width is what? 3 times the depth. We also are told that the height is 5 times the depth. What's the only one they're not talking about having a depth? The length. So what do you think they're actually mean? That the length is the depth. Okay? Because there's only 3 dimensions to a box, a width, a height, and a length. They tell you that there's a width and a height. They're not talking about anything other than those 2 and a depth. So the depth has to be the length. So can we put this all together for our equation? That means that our volume, V, which we still don't know what it is going to be just in terms of D. So D times 3D times 5D. And so that means the volume of this thing will actually be 15D cubed. There is part A done for us. We now have a volume of our box only in terms of the depth. So in part B, when it says, hey, what would be the volume if you have a depth of 1.5, it's pretty easy to do, yes? Just plug it into our formula we just created. So V equals 15 times 1.5 to the 3rd power. Does anybody recognize that's 15 to the 4th power over 1,000? How did I just figure that out? Why did I just make that connection? What's 1.5? Isn't that the same thing as 15 over 10? And if I cube something, a fraction, I can cube the top and the bottom. So that'd be 15 cubed times 15, which is 15 to the 4th, over 10 cubed, which is 1,000. So if this number would have been nicer, because I know what 15 squared is, that's 225. When I start getting into 15 to the third or fourth power, I guess I kind of lose it a little bit there. But if it would have been a nicer number, like a 2 or a 3, I could probably do that in my head. But if not, we take our calculators out and we find out part B, the volume of this particular box would be what? 50.625. So 63 inches cubed. So that's part B. This is really not that bad. Even part C, it says, wait a minute, we have this cool equation. What if I told you the volume? Can you tell me how deep the box would have to be?
Well, sure.
Well, why not, huh? So instead, I'll put 90 here, right? Equals 15 times not 1.5. D cubed, yes? Solve D. Now, let's just put a couple things together here. We say that the depth of this box is going to be bigger than 1.5? Or less than 1.5?
Bigger.
Why would you say it's going to be bigger?
Because the volume is greater.
The volume is bigger, so it has to have a bigger depth, right?
Yes.
So to solve this, the first thing I should do is divide by 15 and then cube root it. But let's get our steps done first. What's 90 divided by 15? And now I'll take the cubed root. D equals 2? It's not 2. 1.8. 1.82 inches. Yes?
Yes.
So 1.82 inches would be the depth if I wanted to have a volume of 90 cubic inches. This is nothing, I don't think anything new here. This is all just using the equation after we've built it. The last one is not an equation. What's the last one going to have to be for part D? For what depth is the volume greater than 60?
Inequality.
It's going to have to be an inequality. How would I set that inequality up? So 60, I know I'm going to have then 15d cubed. Which one has to be bigger? The 15d cubed. Can I be equal to? No, it's not equal to. And now you just solve it. Now, the biggest thing that if I had an inequality I need to realize is that if I multiply or divide by a negative, I have to do what? Flip the inequality sign. I don't have to deal with that right here, but just make it
What was that? You multiply or divide?
by a negative. You would have to flip the inequality. So I get 4. I think everybody would be okay with that. 4 is less than d cubed. Same step as before. Take the cubed root. D is greater than what? Cubed root of 4. 5'9". And that would be inches. So as long as the depth is bigger than 1.59 inches, you will always have something of a volume larger than 60 inches cubed. It's not that bad. Okay, guys. And here, guys, I brought back those guidelines for modeling with functions we had probably in 1.6 or 1.7. So talk about it really quickly. We're just going to express the model in words. That would be the proper thing to do. Like I should have wrote out volume in words equals length times width times height. But it's one of those ones we know by heart. We know it really well. What I might want to write down is what if I gave you a problem about putting taxes on something. Because there's a couple different ways. If I wanted to know the price I would pay after taxes of buying an item, you would have to say, oh, the total cost is equal to the item's price plus the taxes times the item. Right? Kind of in that way. Or we could have said that it's 1.1 plus the tax percentage times the product price. There's a couple different ways. So you might want to actually say it in words first, and then step 2 is okay, L stands for length, W stands for width, those types of things. So guys, we don't always do every single one of these steps, but the more you can start to take the habit of doing this, and I'm trying my best to model it that way as well, sometimes I even forget, the better it's going to get when things get harder, okay? And then 2 is actually take the variables and create the equation. V equals LWH. That's what we did in the last problem. And then we can solve it using the model. Be careful, guys, because if you remember some of our problems, the answer to the equation is not the answer to the question. You may be able to figure out how many cookies were ate in 2 hours, but then maybe they'll say, what if there were 10 people in attendance? Well, no, you have to take the 10 cookies or whatever and multiply by 10 or whatever. So in those lines. So it might have to take it one step further because you only found it for a certain part and you need to extrapolate that to a larger group or thing. Questions on that? This is all on there. I don't know if I want to wait too long. So the first problem, or I guess the problem that we're going to do today that's going to take up the time, is that this is a classic fence problem. This particular fence problem, once you put a fence all the way around a garden, and you only have 140 feet of the fencing. There's many variations upon this problem. Some of the variations will include what happens when I have a fence that can be placed against a wall or a side of a building, where you don't need a fence. That changes the equations a little bit. So, but the whole thing here, guys, is that you have 140 feet. Part A, give me a model for the area. 2, for what range of widths can be greater than, so we have to have an inequality going on. Step 3, can she even have a garden that has an area of 1,250 feet? And then, part D, we're going to maximize this. What are the dimensions of the largest area of fencing in area? Doesn't tell me what is the largest area. Because I think if you solve part D first to find what's the largest area she could have, then in part C, you would already know the answer to that. So, we got to go to part A. Part A says, let's find a function that models area. Wait a minute, I know area of a rectangle. We could write down area of rectangle equals what? Length times width. I think we're past that point for that formula. We should be able to go right away and automatically know that area A is equal to length times width. I think, can everybody understand that? We would all get that. We're past that. So that's the area formula. Cool. The only problem is that it doesn't tell you L, and it doesn't tell you W, and it doesn't tell you anything of a combination of them, does it? Except for the fact that you have how much? I have 140 feet. The 140 feet actually is the what of this problem. The perimeter. So not only should I have an area formula, I need a perimeter formula. What happens to be a perimeter formula? So perimeter P is equal to 2L and or 2 times L plus W. That might be easier. And the cool thing about this one is we know one of those numbers. We know P. So can I say that 140 is equal to 2 times L plus W? Yeah. Or divide both sides by 2 and get plus W. So now I have 2 equations. I have this one and I have this one. Well, let's see. It wants to find a function of the area. So we're definitely going to have to use the area formula. But in step 2, guys, this is kind of the key. I've got 2 equations and 2 unknowns. Therefore, I actually can put these together. In step 2, though, it's asking me to find a range of widths, which means in my function, if I put those together, I want to keep what letter? I want to keep the w's. Because if I get rid of w's, I'll have to find l's, and then I'll have to go plug it back in to find the w. I don't want to do that. So therefore, how can I place those 2 functions together in a way that keeps w and gets rid of l? Minus the what? W. Minus the w. Why? Yeah, then I'm going to substitute. I'm going to say 70 minus w equals l. I'm going to get rid of the l's because all the l's are equal to 70 minus w. So, I'm going to place this there. So area is equal to 70 minus w times w. Wait a minute. What is that thing? It's a parabola. And maybe a better view of this would be to distribute in. And what's so special about this parabola? It opens down. So therefore, it will have a maximum, which would make sense for part D. Yes? Okay. So, we now have a formula. We're done with A. How do I move on to part B? How can I make this thing work?
Inequality.
Create an inequality. What's this inequality going to look like? What does 825 stand for? The area. Excuse me. And what does this area have to be? Thank you.
Greater than 825.
It has to be greater than that. So actually 825 would be smaller than 70 w minus w squared. And now I just have to solve the inequality. How do I do that?
Subtract 825.
I can subtract 825 from both sides, set it equal to 0, basically, right?
Yeah.
What if I said that might be a more difficult way? It's not more difficult, but it has qualities when I bring 825 to the other side that maybe I don't like. What would be that quality that I don't like? It's a negative w squared, a negative a value. You guys recognize that if I actually bring the w's to the other side, I'll end up with a positive a value. I personally like that better. So, without having to show much fanfare, because we're going to save some room, you guys should be showing this. Would you guys agree that this should be w squared minus 70w plus 825 would have to be less than 0? Notice that's not less than or equal to, because I'm not allowing it to equal 825. Right. Then, we can solve it. Off the top of my head, I can think of 4 ways to solve this. Factor is one of them. But 825 and 70 are kind of scary numbers sometimes, right? 2, complete the square. 3, quadratic formula. 4, graph it. Put it on a graph and find the x-intercepts. Yes?
Let's do decimals.
So, okay, I'm going to say you can't use graphing. So, of the other 3 choices, I always generally start with factoring. I kind of sit back and ask myself, are there numbers that multiply to 825, but yet add to negative 70? First of all, the numbers would have to both be negative, yeah? So we know it'll be a w minus and a w minus. But are there numbers that multiply to 875 but then add up to 70? What are they? Yeah, it's 55, 15. So, if you didn't know that, you guys could use the quadratic formula or completing the square. Those all four techniques work, guys. So what does this mean? That if I was to solve this W equals 55, W equals 15, but unfortunately it's not two answers, it's looking for a whole bunch of answers, right? So I need to do what? Make my number line. Are these endpoints included or not included? They are not included. Now, here's the thing, guys. We didn't draw a little sketch of this, but if I did, you guys would agree that it would be upside down parabola. At least our original equation here. Yes? Now, what I'm actually trying to do is state where does that equation greater than 825. There's a couple ways to graph this. I could graph both sides separately and then look for where they intersect. And some of you guys did a lot of that last year. So if I even think of this, it would look a picture like this. Where are the values bigger than that line? In the middle, the top part. So if I was actually thinking about this, where do you think you're shaded? In the middle. But to check that algebraically, could I put 0 in and see if it's true? And if 0 is not true, then it must be on the other side, right? Think of it this way. Because of this diagram, we know we're either in the middle or above or below. So if I'm not on the side, I must be in the middle. So if I'm not at 0, that means I must be in the inside. I'm not over here either then. Or vice versa. So, if I choose 0, put in 0. Is 0 bigger than 825? No. So therefore, I have to shade on the middle. So, you would tell me the answer to part C would be what? $15 is less than W, which is less than 55, right?
Yeah.
What if I said interval notation?
Then you just write parentheses in
And parentheses again, okay? Either one of those would work for part C. Oh, part B, sorry, not C. It's part B. In part C, she just wants to know, can she even have a garden of an area of 1,250 feet? So in that case, I just take my equation and set it equal to 1,250 feet. Can you guys agree with this? So I'm going to change the page. There's my equation. I want to know, can I have 1,200 feet squared as an area? Does it even go large enough? Do I have enough fencing to make that happen? And so, we just explained, hey, just take that as 1,250 feet equals 70 W minus W squared. And solve it. Now, isn't this kind of the same situation as last time where I have a negative W squared? So, again, bring everything to the left side. Now, there's going to be a slight difference of what we did last time to this time, because now it's set equal to 0. Can you guys all agree that I could graph this? I could complete the square, I could quadratic formula, or I could factor this, yes?
Yeah.
But here's the thing. What was the question? Can she? Does it ask us to actually find the dimensions that would make it true? No. So it's just a yes or no answer. But I need to back that up with some work. So, do we have some kind of technique to figure out if a quadratic has answers or not? Yes. What was that called? Not the vertical line test. That tests functions. Whoever said that one. It starts with a D.
Derivative. No.
Not derivative. You guys don't know this.
Discriminant. There it is.
The discriminant, guys. So, discriminant. What was the discriminant?
That's the under the radical.
Underneath the radical, b squared minus
4ac.
4ac. What was the thing about this? If this was positive, we know there would be how many solutions? 2. If it was equal to 0, there would be 1 solution. And if it was negative, no solution. So now all we have to do is just test this. What's b? That's negative 70 squared minus 4 times 1 times 1,250. And if you put all of that onto your calculator, you will say it is a negative 100. So therefore, no, she can not. No, she cannot have a garden that big. She's dreaming. Will you guys agree with this? The last one, guys, is find the dimensions of the largest area that she can fence. Essentially, take this equation and maximize it. Notice that this one is not, again, asking what is the maximum area, because if I knew that, then I wouldn't even have to even think twice about part C, right? It would have told us the maximum is less than that, so I don't have to worry. But I just need to take this equation, and the quickest way to find the maximum of a quadratic in standard form is x equals negative b over 2a. So I just need to figure out this. Oh, wait, it's not x equals because we're not in x, we're in w. So if anything, take that out and put the w equals. So if I know the w, then I can go back and find L. So what is V? So we're using this equation here. So it'd be the opposite of 70 over 2 times
1.
Negative 1.
Oh, yes.
Which would be negative 70 over negative 2, which is negative makes a positive 35. And L, if you remember, we found L is equal to 70 minus W. So 70 minus 35 is equal to 35. So the dimensions of this rectangular plot of garden or fence is 35 by 35 feet.
What's the question? What's the area?
What is the dimensions? And of course, if it did ask us for the dimensions, you would just take 35 times 35, and you would be just over probably 1,000 or just under 1,000.
It's like 135, like that.
Does anybody happen to know? What's 35 squared? Matt, what's 35 squared?
1,200. Told ya.
So so if we knew that answer right there, we could have done part C real easy. Nope, can't do it.
Yeah.
Homework for day 1, because we did not finish all of it, is page 214, 1 through 12. Have a fantastic day.